We are solving two questions in oscillatory motion from the NEET topic. The first question is this. They are simple, so I am solving them together. The distance covered by a particle undergoing simple harmonic motion in one time period is how much, right? So what we can say is, what is an oscillatory motion? I need to find out. One oscillation means it's starting from main position, go to extreme, and come to interim position. Or it can start from interim position, cross the main position, go to extreme position, and then reverses, comes back to main position, and again back to interior position. That is called completion of one oscillation. So what's the journey during this stuff is, this interior position to main position has covered some displacement A, distance also of course A. From there it has gone to extreme position, there also it covered another distance A. So the total distance covered by half the oscillation is 2A. Then it has started coming back. If you are talking about displacement, you could have taken that as negative, but he wants the distance covered is a scalar, only magnitude is important. So it covered another A. Again from main position it came back to this position, it covered another A. That implies what we can say is total distance covered in one oscillation is 4A. And of course, if you want total displacement is needed, that's equal to 0 because it started from the point, came back to the same point. So be careful. Distance covered is 4A, but displacement equal to 0. So that's a first one basic question. Let me answer the another question that was given in NEET 2020 from the same topic. The phase difference between displacement and acceleration of a particle in simple harmonic motion is. We can simply say that displacement differs the velocity differs the displacement by 90 degree. Acceleration differs the velocity by another 90 degree. Therefore, displacement and acceleration have a 180 degree phase difference. But anyway, we can prove that displacement of a particle can be written like y equal to a sin omega t. Velocity can be written like rate of change of displacement dy by dt. Differentiate that a. Differentiation of sin omega t is cos omega t because of the chain rule omega. So this value is a omega cos omega t is velocity. Acceleration is again rate of change of displacement of velocity. I need to differentiate that. A omega is constant. Differentiation of cos omega t is minus sin omega t. As for the chain rule, again another omega. So this is minus a omega square sin omega t. So this minus indicates that displacement and acceleration are opposite to each other. That's a very definition of simple harmonic motion itself. So SHM, a particle is said to be SHM if acceleration is directly proportional to displacement and they are in opposite direction. So these are in opposite direction. Means what? They have a phase difference of 180 degree. Pi radian is the answer. 180 degree means. Or I can also prove that actually y equal to acceleration can be written like minus a omega square. This can be written like sin omega t plus pi also because pi means 180. So when you say 180 plus theta, sin of 180 plus theta, then sin becomes sin itself. 180 plus means it will become something like all silver teacups. It's in third quadrant. Therefore, it becomes say a minus, right? So if you want a phase difference between them, between acceleration and displacement, Acceleration phase is omega t plus phi. Sine of this whatever is there is the phase. Minus phase of displacement is something like omega t. Omega t cancels and pi remains. That's the answer for the problem. That's how we solve this problem. Thank you for watching. Well, this is also a relevant question. Easy question, NEET 2019. What he wants is average velocity of a particle executing simple harmonic motion in one complete vibration. I have explained to you in the uh, previous part of the problem while I am handling that when one oscillation completes, as I have told you, started from one place, say entry position, extreme position, main position. It has started from here, it came back. Its distance traveled is 4a, but its displacement is equal to 0. The formula for the average velocity is total displacement by total time. Total displacement is 0, total time is time period, 0 by anything is 0. So average velocity equal to 0. Suppose if he is asking what is the average speed, then it has a value. Why? It's not the total displacement. Average speed means total distance traveled by total time. Total distance traveled is 4a in one oscillation, total time is a. So its answer becomes 4a by t. But average velocity is equal to 0. That's how we solve this problem also. Thank you for watching.